Principle of angular impulse and momentum. Objective of this video, determine the angular momentum of a particle and apply the principle of angular impulse and momentum. Use conservation of angular momentum to solve problem. If you remember, when we learned the moment of the force in a static course, we learned that the moment of a force about a point provides a measure of the tendency for rotation. In the scalar format, the moment find by the magnitude of the force multiplied by moment r, which is perpendicular distance from reference point O to the line of action of the force. In a vector form, the moment calculated by cross product of position vectors and force vector. The position vector must start from reference point, but it can end anywhere along the line of the action force. Now we are going to introduce angular momentum in a very similar way in this slide. In this slide, instead of force vector, we use the linear momentum vector, which is mass multiplies velocity vector. And instead of moment caused by the force, now we have angular momentum, and we show by h, that caused by linear momentum. How we can calculate the angular momentum? The angular momentum h calculated by two different ways, the scalar formulation and the vector formulation. When we're using the scalar form equals to magnitude of linear momentum, is meaning mass times velocity, times the moment or d. Again, d is a perpendicular distance from reference point O to the line of action of linear momentum, which is velocity vector. In vector formulation, the angular momentum calculated by cross product of position vector r and linear momentum vector. Look at this figure. Consider a particle of mass m moving in the xy plane with a velocity of v. The magnitude of the angular momentum of this particle about point O has a magnitude equal to the d times m times v, where d is the moment arm or the perpendicular distance from O to the line of action of linear momentum. The common units for angular momentum h are kilogram times meter square per second or slug times feet square per second. If the particle is moving along space curve and r is a position vector drawn from point O to the particle P, then h angular momentum equals r cross product of linear momentum or mass times velocity. Also, as we can see in the figure, h is perpendicular to the plane made of r and linear momentum. Relationship between moment of a force and angular momentum. Consider a particle of constant mass m moving in an inertial frame as shown in this figure. Newton's second law applied to the particle states that resultant force equals mass times acceleration. Instead of acceleration, we can write the derivative of the velocity respect to the time. And this one is mass times velocity is showing the linear momentum. Also, we can say the resultant force acting on a particle is equal to the time rate of change of the particle's linear momentum. A dot notation indicates the time derivative in the equation. We can prove that the resultant moment acting on a particle about O is equal to the time rate of change of the particle's angular momentum about point O. Considering the relationship between moment and time rate of change of angular momentum, follow this equation. By integrating between the time interval t1 to t2, we got this equation. This equation is referred to as the principle of angular impulse and momentum. The first and third term represent the angular momentum of the system of particles at the instant t1 and t2, and the second term on the left side is called the angular impulse. In case of 2D motion, it can be applied as a scalar equation using component about the z-axis. Conservation of angular momentum. When the sum of angular impulse acting on a particle or a system of particles is zero during the time t1 to t2, the angular momentum is conserved. Therefore, the angular momentum at time t1 equals to the angular momentum at time t2. An example of this condition occurs when a particle is subject only to a central force. In the figure, the force F is always directed toward point O. Therefore, the angular impulse of F about O is always zero, and angular momentum of particle about O is conserved, and H or angular momentum always constant. Let's look at some examples. Two identical spheres are attached to the rod, which rotate in the horizontal plane. The spheres are subject to the tangential force P, and the rod is subjected to a coupled moment M as a function of the time, where the t in a second. Find the speed of a sphere at time 4 seconds if the system starts from rest. The rotation happens in the horizontal plane, so we have to apply the principle of angular impulse and momentum about the axis of rotation, is meaning the z-axis. The system starts from rest. Therefore, the angular impulse at time at the start point is 0. And the rod is subjected a coupled moment m. We have to integral of the m respect to the time from time 0 to time 4. And also the spheres are subjected to two tangential forces 2 and 10 newtons. We have two spheres times force times this one is a moment arm is 0.5. And we have to integral respect the time and the range from time 0 to time 4 seconds. And angular momentum after 4 seconds, we have to find the velocity. When we solve this equation, we can find the velocity at time 4 seconds. The velocity is 10.4 meter per second. The two balls are attached to the end of a rod that the weight of rod is negligible. A torque acts on the rod as shown of this equation and the m as a function of the time. Find the velocity of each ball after 3 seconds. If each ball has a speed of 2 meters per second when the time is 0. Again, we have to apply the principle of angular impulse and momentum about the axis of rotation, is meaning the z-axis. First, we have to find the angular momentum when the ball at the start point and also after the 3 seconds. We apply the angular momentum for both of the ball. About the angular impulse, we have to integral of the m respect to the time and the range of the time from 0 to 3 seconds. When we apply the principle of angular impulse and momentum, we can find the velocity of each ball after 3 seconds. And the velocity is 3.5 meters per second. Thank you for watching.